Thank you, sir, for welcoming our rector, sir, and registrar, sir. So now we request Professor Bijoy Kumar to present his topic or speak on his topic like TeamViewer and LabVIEW. To Bijoy, sir. So you are.
Yeah, please.
Yeah, here it is.
Give the permission for the screen sharing.
Sir, you have the permission now.
I have. Okay, so before going to this, I would like to say that when there was a meet with the deans and chairpersons with the vice chancellor, in that meet, I proposed that in addition to the theory classes which we are taking in the various platforms, it is also possible to take practical and lab work of science and engineering schools, which is an integral part of the syllabus. And this can be possible, though it is not a trivial solution. It is definitely a non-trivial one, a TeamViewer and a LabVIEW, if you want to do something benefit for the students. But for that case, we need to we need a support from the faculty or the instructor at my computer end of the TeamViewer. Then Professor Sander called me and asked me if I can give a talk. So thanks to Professor Sander. At the beginning, I would like to say that I will suggest all the, I'm just suggesting, social science and the humanities faculty, please ignore my talk. It's going to be really how do your best.
So Professor Bijoy, I discussed this with, but many humanities and social science faculty are also interested in knowing how science works. So I think it will be interesting for everybody. So you don't have to worry.
Okay, yes, sir. We had a lot of requests that we would like to listen to you, sir.
Okay, thank you very much. So at the preset, what I will say is science labs are traditionally served as a workspace where experimental inspiration gives to the future scientists who are inside our student community. Aside from muscle memory, this first-hand experience also gives the students the chance to see before they believe what the professors are saying. So to witness the color change that the professor assured the student in the chemistry lab, that would happen. To be by the self-hand that mix these chemicals and then in the appropriate format, or they can witness the three-dimensional growth of a bacteria, or they can go for some physics lab to any experiments of such. So to do this, what I will say is that over the past few years, we have already seen a lot of scientific experiments shared online from YouTube to the science journal such as JOVE, J-O-V-E, which publish videos of scientific experiments from laboratories around the world. But replacing the labs with videos may rob the student of another important experience from the lab. But in this kind of unusual situation, we have to engage the students for their lab requirement to complete their semester system. So online labs may pave the way for flexibility, which may ensure that many more have the opportunity to do science. Then there is the issue of diversity. Till now, what we learned is many platforms which are already designed by the professionals. I'll give forward with my experience only. This is, I have not done anything else. This is just my experience with the TeamViewer and the LabVIEW. Integration of these two, what I can say is we can able to engage the students in the lab work, in the practical of their lab work. Also the PhD students or the MTech thesis students, so that they can finish their labs, some of the labs, if not all. So again, I'm submitting here that I'm not promoting anyone, any of the softwares. I'm a user only. So what I'll say is, can you see my screen?
Yes, we can see your
okay.
screen, sir.
So can you make your class online in real time? So we heard many talks that Zoom, Google Meet, and everything is there. Also, you can put your PowerPoint slides online. You can also share your YouTube videos related to the topic, or you can make your own videos and post them online for the practical purposes. Now, what I'm going to tell you here is, can you make your students' involvement in the practical lab or the research work remotely in real time? The answer is not so trivial. This is non-trivial. So to do this, I put forward few salient features for this. It is convenient to control the experiments remotely by driving motors, controlling heaters, generating some electrical signals, can be a sine wave or a cosine wave or a rectangular wave. Measurement of control interface designed for use in science and technology labs. Therefore, must provide both digital and analog input-output functions. It should be low-cost interface. Experimental apparatus and sensors are readily available in the commercial suppliers. Some knowledge of electronics is essential for the understanding of online experiments. The design of laboratory course in training program for future physics and technology teachers, therefore, need to be more specific. So they have to modulate it. So what we need is a computer with a data acquisition card. This is the most important thing. The I/O system, sensors, and software and experimental apparatus adopted need to be strongly interrelated. The requirement is a fast analog to digital converter, a multiplexer to maybe an 8-channel one, or few digital to analog converter, the DACs, and the 8-bit or 16-bit outputs, 1/8 digital inputs or the direct supply, DC supply. Now, just to say that there are sensors and interface, these are available even for, I'm just not talking about the physics or the technology students, but these are also available for biology and chemistry students also. And they are offered by a company called as Vernier Company, Oregon, US. There's the website for them. So for this, I have divided my talk something like this way. How the students' involvement in the lab remotely. One side is our fixed experiment group, which are undergraduate students or maybe the master students, which have a fixed set of experiments to perform to complete their syllabus. Next is the research group. Those are the PhD students and the MTech or master students. Those have to produce a dissertation. Now, if I say the undergraduate students, they have various modules available in the market with PC interface that can be applicable with the addition of TeamViewer. Now I'll come to the research group. These are research group and these are full-fledged dissertation or thesis. It can be done by simulation work, by use of the server, workstation, or the LAN of everything. Or the second part is the pure experiments using the different hardcore equipments or the setups. So the simulation one, it can be done through the TeamViewer or the VPN, the virtual private network. But the pure experiment, they cannot be done through TeamViewer only. They need to have the TeamViewer in combination with the LabVIEW program. How to go ahead with this is, before going to complete this slide, what I will say is, these are not really, one can do the real-time computer-based classic experiments. And also in the simulation lab, it can be done completely 100% because many softwares are available. We also bought many softwares which are installed in AIRF, which people are accessing, I guess, through VPN connection. So like a VLSI design software from Synopsys, a VLSI design or the DFT, the density functional theory from quantum restoration, to do the band structure calculations. Say, for example, you are preparing a sample of say silicon or any kind of new materials. You can do the band structure calculation. Not only the band structure calculation, you can do a PN junction calculation, how the PN junction is behaving. Also, how the transistor is functioning. It can be a BJT, or it can be a bipolar junction transistor, or it can be a field effect transistor. what we do is a spin FET, spin FET, the spin controlled field effect transistor. So also you can do the high frequency electronics like HFSs, the high frequency structure simulators, or the CST all sitting in your home. You do not have to go to the lab, or you do not have to go to the server room. You can control it from your home itself. Now, saying this, let me go to the next slide. The team viewer. The team viewer is nothing but a computer software package for remote control, desktop sharing, online meeting, web conference, file transfer, represent presentation between computers. What I see here is you have to go to the team viewer page. You can download the basic version. This is free. Then click on the installation menu. So if you say this is a non-commercial use and the personal use, they will not charge it. Then you will say the accept. This is for the first-time user, how to download the team viewer and make use of it. Then after this, if you start, what you will see is you have two windows. One is the partner window or partner computer, and another is the my computer. Now, from the my computer side, you are accessing from your home, and partner computer means, say, for example, it is your server room or the LAN or the workstation room where it is in the JNU lab or somewhere else, maybe in the other part of the world also, anywhere. Now, next step, it will ask when you click to connect, it will ask your password of your partner computer. You have to put that that password. You have to know that thing by asking someone in the partner computer side first to install this. So that is needed. Now, if you have this, you have the remote desktop, and the remote desktop, you can see it in your laptop like this way. That is a screen sharing basis. So just how you can see how you can control this. Now you have the control or the access control to give to your the viewer what all you want to give and what all you do by this way, just to configuring your system. After doing this, what I will give you is a video that we have made. One of our DST Inspire faculty, he made this. He is doing the simulation thing, and I'll show that thing here.
Hello everyone, I'm going to show a process.
I hope you can hear it.
Servers and workstations remotely.
Yes, it is audible, sir.
For purpose, I am accessing these machines by software called TeamViewer. This software is available in two versions. One is freely available for personal use, and another one is commercial one for professional use. I show here step-by-step procedure to install, connect, and working principle through this software. This software can be installed and work in both Windows and Linux systems. And here, basically, I'll be showing one for the Windows version. To use this TeamViewer, we need one client machine and another one is host machine. Here, the client one is from where you want to access, and the host one is where to access. Here, my laptop is my client one, and the office desktop is my host one. We have to install the software in both these two machines. Now, let me show you from where you will get this software. If you just click on this link, TeamViewer, as I typed in Google, you will enter in the official page of this TeamViewer, where you can see two options. One is download for free, another one start a free 7-day business trial. If you just click on this download for free, it will automatically download this software. And if you just click on this one, you will get the instruction to install the software in your machine. I already have one installed version of this machine. The icon of this TeamViewer is showing here in my laptop desktop. If I just click on this icon, it will open up this page. In this TeamViewer login page, there are several options in the left panel that you can see here, like remote control, remote management, meeting, chat, and many more. I'm basically interested here about remote control, so I'll not go into the other details of these other options. So I'm basically discussing about this remote control here. In the middle, you can see there are two numbers. One is the ID of the user of this laptop and the corresponding password. And in the right, there is one option, it is called partner ID. So you have to put the number, the ID number of your host desktop, that means here is my office desktop. And then there are two options like remote control and file transfer. As I am interested in remote control, so I will not click on this one. This is automatically selected. Now, if I click on this button, it will automatically ask about the password of your host computer, that is my office desktop. When I put this password, immediately it access my office desktop. I given the password of my host desktop, that means my office desktop here, and if we click on this logbook page, on desktop. Now, if we see that one, so the first time, if you want to use this wallpaper one, okay, I wallpaper of the desktop will appear and visualize everything there. Your office desktop, your remote laptop. I can immediately access all the software that is installed in my office desktop here. Moreover, this office desktop that is connected to my server or some other directory. So we can access this desktop. If I through this and extra button, if I click on this one, then one option like file number. So if I can download the file from this desktop, or I can upload my file to the desktop.
Vijay, is it possible to increase the volume somehow?
I am accessing
Mic
क्या कह
nearby.
रहे?
आवाज शायद कम आ रही है लोगों को. माइक इसके क्लोज कर सकते हैं कंप्यूटर के?
ये तो रिकॉर्डेड है, इसमें मैं कुछ
आपका माइक जो है अगर इसके क्लोज करेंगे तो शायद इसमें आ सकते, या आप इस पे प्ले कर रहे हैं अपने कंप्यूटर पे?
मैं इसको प्ले कर रहा हूँ, अपनी कंप्यूटर को प्ले कर रहा हूँ. This is the only sound I have.
The video has low sound, that's why. And it's
Yeah.
sharing with the computer sound.
Okay, so we
I
can't.
think we have to. Yeah, it is going to
Maybe
be
you
less
can
now.
explain. Maybe you can explain like what is being said, and then video can be played at the background.
Okay, so he double click on the.
installed in my office desktop to connect with my servers.
He's connecting the server through his
After
office
connecting
computer.
my servers,
So maybe
software
you can silent
Sorry?
voice. You can make this particular sound silent
So
and explain.
You can mute the sound of the video, and then you can explain it in your own voice.
Okay. So
my research.
So what he is doing is he is connecting his office computer to the server room, where he has the software called as Quantum ATK from Synopsys to do the DFT calculator, density functional theory calculations. And then that is in the server room in the nanoscience center. And then he's opening the pages from the server, and he is going to show one result, what he has already calculated. And this is the band structure calculation of a silicon semiconductor. And it is not necessarily a silicon, it can be any sample. So by using his TeamViewer and his office computer. He is remotely accessing his server room and doing the band structure calculation. And it is just not the band structure, as I said. It can be a PN junction, it can be a transistor, it can be a BJT or a FET or any spin FET or spin BJT. Everything he can do it from his home. And he is Dr. Ramakrishna, and he is guiding few of my PhD students, also few of PhD students as co-supervisor, and doing the density function theory calculations. So this is all about the video for how to connect to your server room and do the calculation and engage the students to do their research, whether it is a PhD student or a MTech student, by useful of all of them and engage them. Now I'm closing this one and then coming back to my slides. Now the next part is even more trivial, because the earlier one which you saw, you can control fully by sitting in your home without any intervention or without any presence in the other side of the computer. Only just the password is needed when you reboot the system. If you know the password or ID, then you do not have to go to the server room, or the server room can be anywhere in the world. It doesn't mean that it is in the nanosite or in the JNU. So if you have those two numbers, you can access the computer, the other side of the computer, and do it. Now I will tell about how to go for this second one. This is a really non-trivial one, as I said. It requires some hardware experience along with the LabVIEW and the TuneViewer. So in this, what we have done is, in this, I will introduce few LabVIEW basics. The remote access of measurement setup from distant location. It can be other side of the institute, laboratory, in a different building, or anywhere in the world if it is possible. You can remotely access data, you can analyze them, or you can write a final report on this. Now, what is a LabVIEW? A LabVIEW is a laboratory virtual instrument engineering workbench. This is a graphical programming language that uses icons instead of lines of text to create the program. So LabVIEW program called a virtual instrument, and they produced by the National Instrument. So LabVIEW is a very loved one tool for the scientists and the engineers. Now, few points, salient points for this LabVIEW. So in this part, we will discuss a tool which helps to automate the testing and the measurement equipment. Not only automate, but also gather experimental data. The tool is the LabVIEW. It is also a graphical presentation programming environment, which is widely used in the experimental research lab, industry, and academics. It is an instrumental software system and a competitive analysis tool used for the measurement and automation. The language used is called the G, the graphical programming language. Using the graphical programming language, it eliminates the use of text-based or the syntax-based coding practice. Therefore, LabVIEW offers more flexibility when compared to the industry standard laboratory instruments because of LabVIEW is software-based. The data controls can be easily managed when the LabVIEW is utilized. Firstly, we'll understand what is LabVIEW is, and then we'll discuss few advantages of using this software tool and go through basic workflow of the LabVIEW. So what is a LabVIEW? A LabVIEW is a programming environment in which you will be able to create program using graphical notation. A graphical notation is nothing but a process where you will be connecting functional nodes with wires, which ultimately depicts how the data flows. Unlike the traditional programming language like C, C++, or Java programming is executed in terms of text, but LabVIEW is not just a programming environment. It offers much more than coding platform. It is an interactive program development system which is specifically designed for people like scientists and engineers. The LabVIEW environment works on a computer like Windows, Mac, or Linux system. Next, what I will give you an idea about what is the programming language used in the LabVIEW. As I said, the programming language used in the LabVIEW is G, that stands for the graphical. And next, we will go to what are the benefits of this. The benefits of this are, with the help of user-intuitive graphical interface of LabVIEW, users will be able to avail the following benefits. Having a graphical interface makes LabVIEW easy for programming. It is ideal for simulation. A user will be able to present how the data flow happens within a virtual instrument. It's not a real, but a virtual instrument. Easy for generating programming, basic programming concept can be taught. Completely flexible in terms of creating a virtual instrument according to your requirement. You can easily modify a virtual instrument as and when you want to change them. Has extensive libraries of functions and subroutines. These can be used for programming tasks, thus eliminating the fuss of having pointer memory allocation, often the troubles that occur when a traditional programming language we write. Contains specific libraries that are related to data acquisition. These libraries are useful for data analysis, data presentation, data storage, and ultimately the communication. So LabVIEW has specific analysis libraries which have useful functions like signal generation, like a sine wave or cosine wave, a signal processing. It can have a filter also, it can windows, regression. All these are used for analysis. The output data can be presented in any graphical format like charts or graphs, etc. So LabVIEW program are portable. That is, you can write a program in Mac and then execute it in the Windows machine or vice versa. Now going to my next slide. LabVIEW programs are called the virtual instrument. These are not real instrument, or these are called in the short form is the VIs, because their appearance and operation imitate physical instruments such as oscilloscope or a multimeter or a power supply. After build the user interface, add code using the VIs and structures to control the front panel objects. The block diagram contains this code. Here is the main part of this. The main part, why I'm saying is that we are sitting in a physical world. It can be an analog world, or it can be a digital world. It can be any physical variable, like a sensor, a temperature, or a timer, or a counter. How to integrate them to the computer? So first of all, what we have to use it, we have to take the data, convert them to the digital world, digital signal with a analog to digital converter, and then transfer this data to a data acquisition hardware. And how will transfer it? By a GPIO card, and then this will be fed to your computer. And here in the computer, you'll write your LabVIEW program. So the data acquisition is the process of gathering or generating information in an automated fashion from analog and digital measurements such as sensors, devices, and a test. Next is, okay, this is how the software looks like. So this is the front panel, and this is the block diagram. What we see in the computer, the front face of the computer is like this. What we have to develop is like this. Instead of writing and encoding language, it's just the short form, the emblem, and then you can put it and then wire it, and then your program is ready to go. Just going through one by one. This is the front panel. So front panel has the toolbar. Then you have a Boolean function. It can be 1 or 0, off and on. So now you have a waveform graph. You have a plot listen here. And here is a graph listen. You can run your earning average. So you have the y-axis at the degree Fahrenheit. And x-axis is the time. So this is what you have to do it here. And the back also. The plot listen is the time. You have to write here, whatever you want to write is the time, the x-axis, and degree F Fahrenheit in the y-axis. The scale listens are there. In the above screenshot, the user will be able to see the graphical code. The graphical programming helps the user to understand the data flow within the application. Next is the block diagram. What you can see here is what it depicts. Repeats is this is all the block diagrams for the toolbox, the sub VIs. Then you have the while loop you want to make it, some numeric constant you will make it, timer function you will give, a Boolean control you will give, the off and on switch, the wire data. So you have to connect your some kind of instrument to another one. Or for example, I'll take an example of say in the electronics lab, you are designing a modulator circuit. So you will be able to do this by in a breadboard and then put the components and then connect it. This is by physically. But if you have already an inbuilt one, say a PAM or a PWM circuit board provided by some vendors, for this time only, I'm suggesting, not for always, because I always say making the circuit on the breadboard is the best way of learning by the students. But at this special condition, we can make use of the modules. These modules are always PC based. Then you can integrate this module to your PC. Then by use of your LabVIEW program or maybe some other program, allow the student to the team viewer to operate this. Next is I'll go a little bit into the Real Instrumentation LabVIEW. What we saw here is the LabVIEW first page when you download the LabVIEW, and but this is what I say is it's not a freeware. This is a commercial one. It costs money. It always depends upon how many users are there, how many PCs you are going to install it, and how extensively you want to do this. It may start from something like 1 lakh to 5 lakhs or 7 lakhs, something like that. I don't have the real idea of this. And it all depends what you are going to use it for. So what you can see here in this one is you will get to see the two options. The first one is the create VI or the open VI. The VIs are nothing but the virtual instruments, which are programs that are created in the LabVIEW software. Selecting create VI will create a new virtual instrument. Selecting open VI will give you an option to view an existing VI. For new, let's go to create VI. A new screen will pop up and it will be showing something like this. When you create this, this will come. This is a virtual instrument. It is nothing but a front panel of the screen.
आपकी आवाज कोई प्रॉब्लम है थोड़ा अगर माइक के क्लोज
आवाज में प्रॉब्लम है
अभी बेटर है ये I think you
have to come closer then. Okay. So this is the front panel of the LabVIEW when you created the VI. So the front panel is nothing but the interactive interface for the user. It displays the entire panel where the user will be able to select different options and execute the process. Further, the front panel has push buttons, graphs, knobs, indicators, and other options. The data can be keyed in by using a mouse or a keyboard. The result can be viewed on the screen. While creating a new program, the user will have to decide the inputs and the outputs which will be available. Then place the cursor on the gray area here in this window and right click. A new window will appear, and that new window is nothing but the control panel. This is this way. A control panel will come out. So what this control panel means? So within the control panel window, a lot of options are available. Some of them are numeric control menus, graphs and arrays, booleans and other sets of controls. For this, for instance, let's go with numeric control. So from the control window, select the numeric control menu. Now place the controller anywhere on the control panel and select the digital indicator of the control panel here. So the same is depicted here in this screenshot. These two controls can be used while you create a program. The next step are explained in the next slide here, like this way. The block diagram section, which is nothing but the block diagram. What is the block diagram is? This is the second component within a virtual instrument This is an important area where the underlying code goes into the program. Using the input and outputs, the program is created graphically here in the box. The user will be able to select objects from the functions window. A block diagram is nothing but the VI source code. It is actually programmed in using LabVIEW's programming language, that is G. It is the actual executable program. The block diagrams components are lower level VIs. The constant, program executable, control structure, built-in functions. Thus, the user will be able to draw wires and connect with the object and define the data flow. Next, we will go to how it happens, how the control looks like. So here, what you see here in this diagram is the user will have the access to see the menus. So this is the menu. Just you hover your mouse on top of this. If you are using the program, then it will come out. But here it is written everything. So automatic tool selection, position, the size selection, this one. This is the operator value, the wires here, the set and clear the breakpoints, the probe data. Then you have the object shortcut menu. You get the colors, you have to change it. The scroll window, the edit box where you want to write something. So the cursor is used to change the values. Another scenario, the cursor is used for changing the size and move the objects. After this, we'll go to the functions. There are hundreds and thousands of functions are there, which maybe we cannot finish it in just one talk. People are giving some talk of some 1 month or 3 months talk, the online teaching programs of the LabVIEW. So here we'll explain a little bit here. Now you will see here is a sine signal for a oscilloscope. Then you will have a transfer function. You can simulate this, and you can go to the time waveform. You can stop it for a half simulation. Here you have the structures, arrays, clusters, numeric, Boolean, string, comparison, timing, dialog, input, output, waveform applications. So many varieties of functions are available here. So just to understand what all represent is, to understand the available options, you can just simply hover your mouse and description will be displayed on this. There will be few more of these kind of descriptions or what you can use in the functions here. Yeah, I'm not going into the details of this because this is a full-length kind of a talk. It needs a 30 hours of talk. So just the initial phases I'm just giving. And then what I'll go here is few more simulation functions here, sub-pellets in controlled design and simulation pellets. So simulation loop, continuous, discrete, nonlinear, signal generator, lookup tables, signal arithmetic, utilities, time and linear, graph utilities, all the here is it. But there are plenty of them inside this program. Now go to an example. Creating a VI. Say this is the, as I said, this is the front panel. This is the block diagram. How do you are going to make it?
We have a next speaker. So can you wind up in 5-10 minutes next?
Okay. So just creating this one, and then quickly go to some digital controls for this, and then maybe the wiring. How you going to wire it out? All the functions, more indicators. Help program you can do it. This is an example to multiplication or a summation. This is how to write a program to convert the Fahrenheit to Celsius, the front panel and the block diagram. Then this is what is used in the LabVIEW. Like you have the virtual instrument and you have the real instrument. So in the lab, what you have is a power supply, a CRO, oscilloscope, or a nanovoltmeter. So all the instruments are there in the lab, and through a GPIB cable, you connect it to the computer, and then use of LabVIEW, you make use of this LabVIEW environment to make use of your instrument. This is what it shows in an industrial control panel, and this is what it shows in a LabVIEW virtual instrument panel. Another example is the pressure gauge. You can control the pressure gauge, but you do not have to go to the room where the pressure gauge is there. You can use it from your virtual system. And this virtual system you can see by using your TeamViewer program. One can even, I just put a video of you can control a robot by using your LabVIEW program. Here I'll show you actually what I have used or what I have experienced, how to use the system when I was in University of Colorado before joining this JNU University. Even after 2013, I used to access my US lab, and I'll just give you this video and then I'm done for this. This is my lab in US. Here we have many control systems. Some microelectronics people can understand. The microwave bench up to 100 kilohertz, and the probes. This probes can be controlled, and the device and the test will be placed here. These are the probes with a pitch of 150 microns. So one is to see these probes. There's a single line and a ground plane through a microscope. All these are connected to the PC, and then after you put your system on the device under test, and these are some control panels of the microwave bench. Then I will go to the next one. Here is the another side of another bench. A few instruments can be hooked up. So the thing is that you cannot do the hooking up thing. You have to take help from someone else in the other end. So this is another system what you can use at a probe station, and then you can put the probe here, the sample here or the device here, and land the probes by the use of the microscope. And then using, these are all connected to the computer here, which has a LabVIEW program and also a TeamViewer to control it. So after you connecting to this, you can do your measurement. So I will go directly to ahead a little bit to the last view. So just to show some more of the instrument. So this is another instrument. Okay, I gone too far. So there's a power supply for the magnet, which is also controlled by the LabVIEW program. So this is the computer where we run the LabVIEW. Here in this machine, this is a LabVIEW program. You can see here, this is the LabVIEW front window. You have the data acquisition is going on here with the frequency versus S parameter, scattering matrix parameters of some device. And to do this, only thing what we need is at the other end of the instrument, one has to put the sample. There are some vacuum pumps. The magnet is here. And then this is a vector network analyzer, which is connected. It's also connected to the PC where the LabVIEW program is. There the cabling to the probes where your device is going to be connected. Here inside the magnet, we need a magnetic field. So we put the sample here, if you can see it. And then just to put the sample, and after that you are done. You can control it, everything, sitting any place over the world. I'll just go behind this experiment with this setup to show you how it is hooked up. So here is the GPIV cable where it is hooked up to the data acquisition system. Just next to it, this is here. the data acquisition system, GPIB is connected to the GPI data acquisition, and then from data acquisition to your computer where you have the LabVIEW program. So all these with the help of LabVIEW, with the help of little bit from the other end, you can control your experiments. So this was my UCCS lab, which is in US in University of Colorado, and I can control this sitting in JNU itself. Okay, so timing is not there, so thank you very much.
Thank you very much, sir, for this wonderful presentation. I think like we people from non-science also got to learn a lot of things. You have some questions over here. Professor Dinu is asking about, this is probably applicable for electronics lab. Can you please give an example?
No, I gave I gave the example of electronics lab and physics lab, but it is also available. The only thing is you have to think about how you can control all your physical system, whether it is a biology or a chemistry, to convert it into a digital signal. This can be done. Many sensors are available. Many control systems are available. So if you can somehow convert them to the digital by the use of a ADC card to the computer and feed into the computer, you can do it. Of course, you cannot do many things, many things which the biologists do, many things which the chemist people do in this virtual environment.
Okay. Professor Kutubuddin is asking, is there any possibility to utilize similar kind of programs for language teaching courses?
You don't need to go for this because these are instrumentation. What you have already heard from various speakers, already you have the programs. These are really not needed. And as I said, these are not so trivial. I mean, too much of kind of instrumentation and a little bit of electronics, or maybe you can hire a professional to use this software to, this is kind of a data acquisition from your machines.
So Dinu is asking once again, like a main part of lab is to prepare the sample. How can you do it remotely?
You cannot do it. Very frankly speaking, you cannot do it. First, that's what I'm saying, that all the time you need the help of the instructor or the faculty member who can help you. I mean, I'm talking about for the students. So if you want to help the students, you have to take care of few things. And then after that, you can ask them to measure it, take the measurements. So that is only possible. Or if they have already done it before the lockdown period, you can go to the lab, put the sample in the automated system, run the machine, and then ask them to control from their end by use of this system and the team viewer to operate it, and then take the data, plot the graphs, make the report, and the final submission of the dissertation. That is only possible.
Dr. Ashwani is asking, like, is it possible to do real-time measurement using LabVIEW?
Yes. Through your team viewer, you can do it. Only thing is that you have to have someone to put the device under the DUT. Ashwani can understand what is DUT. The DUT in your test bench or your probe station. And then if you can configure your the probes, if you are using a cascade probes, you can download the probes and then you can put it on top of your DUT. After that, everything, if it is on, if your network analyzer is on, if your power supply is on, everything is on, then you can access it through the team viewer, your LabVIEW program sitting at your home. Because team viewer is nothing but you are accessing the system which is there in the lab.
Yeah, thank you very much. You are getting a lot of compliments, and thank you for this wonderful presentation. And there is one special comments from Surendra Jadavji, who is saying this is really wonderful technique. I can imagine the future teaching, learning, great. So thank you very much, Bijoy, for this wonderful session.
Thank you.
Now we may move on to our next speaker.
Just add one more comment to the
yeah,
benefit of users. the participants here, those who are not in science. So one thing is to access your lab equipment using remote controls. That is what Professor Bijoy has explained. The thing is that some of these experiments may be risky, and in the future labs may be done more and more through computers and through remote control. So some of these experiments are too costly or too dangerous to perform every time. So simulating those experiments and having virtual experiments is also the way for the technology of education in the field of high school science, even in early stage school science.
Very true. Very true.
Okay. Yeah.
Yeah, thank you.
Okay. Thank you very much. Now we would like invite our